So in this video, you're going to learn how to calculate the basicity of an acid through titrametric analysis, that is titration. So refer to the question. First of all, highlight the important elements. So we have 2.17 gram of the sample of even dinoic acid. So here is the chemical formula of even dinoic acid. And we dissolve in the distilled water and afterwards made up to 250 cm cube. That is inside a 250 cm cube volumetric flask. And afterwards, we use a pipette, 25 cm cube, right? To use a pipette to withdraw 25 cm cube of the solution and put into the conical flask. And afterwards, it requires 29.3 cm cube of 0.119 m sodium hydroxide solution for complete neutralization. So based on the information provided here, you are going to calculate the basicity of an acid. So what you need to do, first of all, okay, in this question, since we don't know the basicity of the acid, so we can't write down the chemical formula directly. But what you need to know is inside your brain, you need to have this kind of picture because we do the titration. So 25 cm cube of the even dinoic acid solution will be put over and inside the conical flask. Even dinoic acid solution. And inside the burette, we will have the 0.119 m sodium hydroxide. So how can we calculate the basicity? First of all, calculate the number of moles of sodium hydroxide used. Okay, how can we calculate the number of mole of sodium hydroxide reacted? And he provided the volume for you, and also it gives you the concentration, and you can directly do the calculation to calculate the number of mole. Molarity times the volume, and we will get the number of moles. Okay, the number of moles of sodium hydroxide used will be 3.49 times 10 to the power of -3. And afterwards, what we need to do is to calculate the number of moles of even dinoic acid inside 25 cm cube. So first of all, we have the grams for the even dinoic acid, and we will know about the molar mass. And inside 250 cm cube, we will know the number of moles of even dinoic acid. How can we calculate? That is, so moles of even dinoic acid. Okay. In 2.1 gram will be, okay, we directly do the calculation. We have the grams, we have the mass. So calculate the molar mass here. So we will get 2.17 divided by, so for even dinoic acid, the molar mass you calculate will be 126. And directly do the calculation, and you will find 0.0172 moles. So it means that in 2.17 grams of even dinoic acid, we'll have 0.0172 mole. Also, in 225 cm cube, we will also have 0.0172 moles of even dinoic acid, right? And afterwards, we withdraw 25 cm cube of this solution. So how many moles of even dinoic acid inside 25 cm cube even dinoic acid solution? So the number of moles of even dinoic acid in 25 cm cube will be, since in 250 cm cube we'll have 0.0172. In 25 cm cube, how many moles? We divided the mole by 10 because we only withdraw 25 cm cube of the solution. So in 25 cm cube, we'll only have 0.00172 mole of even dinyl acid. Okay, so now we are going to investigate, find the basicity of the acid. It means that it wants to find how many ionizable proton will be ionized from the molecules. How can we calculate it? So for sodium hydroxide, one sodium hydroxide react with one acid. It means that the acid will be monobasic, such as like sodium hydroxide react with monobasic acid. It will 1-to-1 ratio, 1-to-1 ratio, and we will form something like this. If sodium hydroxide react with a dibasic acid, and we will form something like this, right? And we balance the equation, we will find out that we will use up 2 NaOH react with 1 H2A. That is the dibasic acid. So what I want to stress is now the number of mole of even dinyl acid is 0.00172. And the number of moles of sodium hydroxide is 3.79 times 10 to the power of -3. So the difference between these two number of mole will determine the basicity of the acid. And how can we find the basicity? And that is, since in this case, we have 3.49 times 10 to the power of -3 moles of sodium hydroxide, right? And we divide the number by 0.00172. This number is the number of mole of sodium hydroxide, and this number is the number of mole of acid. So when we divided the number of mole of sodium hydroxide by the number of mole of acid, and we will find the basicity. It means that we need to use one acid to react with 2 hydroxide. So it means that the acid will be dibasic. Okay, what we need to do is find the difference between the number of moles of sodium hydroxide used and also the number of moles of acid reacted. And the difference between them will be indicate the basicity of the acid. So one acid will react 0.00172 acid, mole of acid will react with 3.49 times 10 to the power of -3 alkali, and 1-to-2 ratio. So one acid react with 2 alkali, so basicity will be 2. So for the class practice, we have this question. First of all, for 2A, what you need to do, highlight the information in the question. So we have 18 grams of the acid, and we dissolve it into 100 cm cube of the solution to make the solution. And the molecular mass of the acid is 1990. And you're asked to calculate the molarity of the solution. So it's very simple in this case. First of all, what you need to do is we have the mass, we have the molar mass, and we can find the mole, and we have the volume, and we can find the molarity. First of all, we find the number of moles of HNA, and it will be 18 divided by 90. And you will get 0.2 mole, right? And afterwards, we know about the mole and also the volume, and we can get the molarity. Okay, how can we calculate? That is the mole divided by the volume, and you will get 2m. Okay, so that is the answer of 2A. So it's very simple. So for 2B, and you are asked to react the 25 cm cube of the solution X, that is 25 cm cube, to M of HNA, this solution. And we use up 50 cm cube of 2N sodium hydroxide. So in your mind, 25 cm cube of solution X, that is the acid, we will place it in a conical vase. So here is the 25 cm cube and also 2N HNA, this acid. So, and afterwards, in the burette, what we have put inside burette will be the sodium hydroxide solution. That is 2M. So first of all, and the final question is asking you to determine the N inside the chemical formula HNA. That is the basicity. So how to calculate? First of all, calculate the number of moles of sodium hydroxide used to react. So the moles of sodium hydroxide, so B1 mole of sodium hydroxide reacted. Okay, will be, we have the volume, we have the molarity. So molarity times the volume, and you will get the number of moles. So 0.1 mole of sodium hydroxide will be reacted in this case. So afterwards, we calculate number 2, and you're going to calculate the number of moles of the HNA in 25 cm cube, right? So how can we calculate it? Think for 5 seconds, maybe. So, and now we have the volume and we have the molarity, and you are going to ask to calculate the number of moles. It's very simple, right? So we have the volume, so moles of HNA in 25 cm cube will be, we have the volume, we have the number of mole, that is 25 cm cube divided by 1000 and times the molarity. And you will get 0.05. That is the number of mole of HNA inside 25 cm cube. So that is the number of mole of HNA inside 25 cm cube. And finally, we want to determine the value of N here. So we just simply see how many acid will react with 1 mole of sodium hydroxide or 0.1 mole of sodium hydroxide. The ratio between HNA with the sodium hydroxide. So how can we calculate? That is, we develop 0.1 by 0.05, and you will get 2. What does it mean by 2? It means that 1 mole of HNA will react with 2 mole of sodium hydroxide. So it means that the N here will be 2. So the acid HNA will be actually equals to H2A. So that is how we can calculate the basicity. How many ionizable proton from the acid by considering the ratio, the reacting ratio between the sodium hydroxide. So here is the sodium hydroxide, the number of mole of sodium hydroxide, and also here is the HNA mole. And we calculate the ratio and we get 2, and it means that 2 sodium hydroxide will react with 1 HNA. So only the case the N equals to 2 will react with 2 moles of NaOH. So in the chemical formula, you will write down something like this. So you will form Na A, 2 and H2O. And so balance equation, you will see 1 to 2. So that is the basicity. It means that it is dibasic acid. So that is how we can calculate the basicity based on titration.